hanging out in the hangouts. Away we go. 7-point section. Finding angles, solving right triangles. That's what this one's about. So any of those, sine, cosine, or tangent. The trigonometric ratios discussed in this chapter are unaffected by the size of the triangle, provided that your triangles, meaning less than 90 degrees, small angles, right? You know the trigonometric ratio, sine, tangent, or cosine of an angle, the size of the angle. This requires an inverse operation. You can use your calculator to find the opposite of the usual ratio calculation. You could think of the inverse in terms of addition. They undo each other. That's what we mean. They're opposites of each other. It undoes the operation. Now, this is just to learn how to use your calculator. So here's what we're saying. Sine of some angle A gives me 0.2546. So you know how we always put in like the sine 30 degrees and you get decimal 866 and so on. Well, here we're told what the decimal number is that you get on your calculator. What was the angle you put in? Solve it. Rewrite this right beside here as A equals, because this is the angle, the sine, and then this is, and then we'll talk about it. This undoes the sine, sine -1 of 0.2546. Now, how do you calculate is the important thing. You got to be with us. So, on your calculator right now, you're all in degree mode. You're probably going to use either second function or a shift. It's usually at the top left corner. I know yours has it. And Brooklyn, your calculator is going to be, you're going to put in the 0.2546 right now on your calculator. I do believe, Isaiah, yours is opposite. Different. I'll talk about yours totally often. Okay, so you put in your 0.2546, right? Now, is your top thing shift? Hit shift and then hit the sign button. You'll notice where sign is above in the printed thing. It says sign. What do you get? Okay, you did it. I see. Did you put 2546 first? Decimal 2546? Try it again. Whereas Isaiah and Tori, you're going to hit the second function or shift button first. And then it'll come up sign -1. And then you'll put in 0.2546. We'll see what you get. Round it off to the nearest degree. 14.7. 14.7, good. We'll round it up. 15 degrees. Now, Isaiah, did you get 14.7 and round it up? Did you? Did you, Tori? Okay. Check, because I know yours works. Is it checked it? Okay, sure. This second function button first. And then you hit the sign button. See that sign -1, and then put 0.2546. Yours. Yeah, it is. But yours is sign 12546. Okay. The same way, except these are cosine and tangent. So first write down what we're going to put in the calculator. The angle B is equal to the cosine inverse. The cosine is not a power, though. It's just saying inverse. 0.1598. You'll get whatever degrees that is. And C is the tangent's inverse. Now, put those in and get me some degrees for both of them. So we know for sure you know what's up with your calculators. One. finish recording and then sit with you if you remind me, okay? Got it? So what does that round up to or down to? 80.8. The degrees, no decimals. 81. 80.8. Bump it up a notch. 1. Yep. Sure. Okay. You got chapter 6 stuff? Okay, good. I'm sorry? Never mind? Okay. Can't hear that though, that's all. 73. Sounds. 73. Yeah, 73. So, now what? Try example 2. We'll use these skills. You know how to do this. Isaiah, settle down, turn this way. Thank you much. Okay, determine the angle of elevation to the top of a 5-meter tree at a point 3 meters from the base. We got to visualize this. It's a tree. We can just draw a stick for a tree, but a tree generally goes up and down. So draw a stick to be the tree. Okay, you got a tree. Now that's a 5-meter tree. Drawn it on the left side so I have space on the right to work, right? Now, we have to draw 3 meters from the base. So if this is 5, we've got to draw, where's the base, on the ground or in the sky? On the ground. Over. Okay. Let's make this a triangle then. Determine the angle of elevation. What is the word? Folks, it's pretty rude. Thanks. What is it to elevate something? To lift it up, to go up. We're looking for the angle of elevation. You see from the ground, this is the angle going up. I put a little circle line in there. It's called theta, right? Sort of like that there on the wall there. I've got theta, sine theta, cos theta. It's a commonly used variable in math. You could have used an x, doesn't matter. Tan of x, cos of x, etc. Now, before we do too much, everybody's good coming up? We should label this triangle opposite, adjacent, hypotenuse according to that theta angle. This is different than the other problems because we aren't given or whatever that is, right? Let's think this through. From this angle theta, what would you call the side? By the way, I'll just jot this in here. We'll assume that the tree makes a right angle with the ground, just to make it simple. Otherwise, we've got to use rules. So what side is the 5? Opposite, adjacent, or hypotenuse? Opposite. Opposite. Good answer. Good answer. Which one's the hypotenuse? The 3 or the other one? The other one, because it's across from 90. So it is. It's beside. It's adjacent. Once you do that, we have information about the adjacent side and the opposite side. Which one of the 3 trig formulas over there gives you opposite and adjacent in the same formula? Sine, cos, or tangent? Tangent. Okay. So what we're going to do is write out the tan of theta, because we don't know what it is. Or you could have used tan of that. I think that's variable. But that's a variable. Is equal to the opposite over the adjacent, right? That's exactly how the rule is written. In this case, we know the opposite and the adjacent, right? The tan of theta is equal to, well, the opposite side is 5. The adjacent side is 3. You guys told me that. Okay. Now I'm going to have to use my calculator. And what's 5 divided by 3? We'll round it too.
2.
We'll round it as well, like as in TOO. We'll round it. But, okay, a little more decimals than that. And it wouldn't even be correctly rounded at 1.6. 1.6. Okay, put it in your calculator. 5 divided by 3, and you tell me three decimal places. 6, 6. Okay, so that means 6, 6, and then what would that?
That'd be 1 and 2.
Whoa. You said it's 1.666, blah, 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 right? We want to round to this spot. Does it stay as a 6, or was the number behind it tell you to do? Higher. 1.6. You're good. I'm making sure they're on. Okay, 1.667. Now, with 1.66, look up above. What did we do when we were given things like tangent equal to some decimal number? How do you undo that? How do you find? That's our new skill. How do you find that angle in your calculator? What do you do? The shift thing. Yeah. So you're going to, I can't do any more with this. I got to find the angle. So the theta in this case is equal to that. Use the calculator. Use the power of the force of the calculator. And then you figure out what the degrees is. And you can round it just to a whole number degrees. Eh? When you do that, Tori, you got an answer for me, right? What's the degrees there? Somebody's got an answer.
$5 and 0.
$5.
1 0 0.
59 degrees, right? And it's degrees. We need that little circle behind it. 59 to say degrees, okay? So, what we learned up here is used down here, okay? You're given a diagram. First, know how to do the diagram. Figure out which function you use by looking, do you have opposite and adjacent in this case, or the hypotenuse would be something else. Fraction, put it in there. Create a decimal number from your fraction. And then it becomes a problem just like we did before, where the calculator does all the work. Okay. One other example here, and this one's got a few steps to it. The new skill is working with ratios to solve triangles. Solving a triangle means finding the values of the unknown sides and angles. In a right triangle, you already know the one angle is 90. Right? And then the thing across is called the hypotenuse. So there's only 5 other parts to consider. 3 sides and 2 other angles. So in this angle, sure. And then this side, and side. Okay. You can use trigonometry to find the other values. Also, you Pythagorean theorem, a squared plus b squared equals c squared to find the other angles. One thing, the 3 angles in a triangle That saves you a lot of work if you use that one. Solve the right triangle. So if I say solve the right triangle, it means find all the sides and all the angles possible. Say to the nearest tenth. That means 1 decimal place, tenths place, okay? Now, the first thing to look at is the easiest thing. How do you find? Knowing that all the angles add up to 180. Well, angle B. This one here. Angle B is equal to. Well, the grand total is 180. We know that, right? 80 minus. What's angle C? Because it's got a little box there? 90. So it's minus the 90 degrees, and it's minus the 56 degrees in corner A. So that's just an arithmetic thing. I'll do it for you. 90 minus 90 and minus the 56, that's 34 degrees. Hopefully I didn't make a mistake. There's other shortcuts, but well, this always works for any triangle, whether it's right or not. If you realize that it's always 90 for the one corner, you just need to go 90 minus 56. But enough of that. This works for everything. So I'm going to show you this way. 180 minus the other angles. Now, we've got a couple of sides to figure out. We've got the A and the B to figure out. Before we try that, though, we should diagram. Now that we have 34 figured out, we're good. 34. So what do we want to do here to figure out? What is this C equals 8.7? Is it hypotenuse, adjacent, or opposite of? We're going to use the 56 as the comparison. We're going to compare everything to 56. What is angle C called of the three? Or angle, I said angle C. Side C. Hypotenuse to angle A. We're comparing everything to compared to angle A.
Okay, so this long like this.
Angle side C. Which one is it?
Hypotenuse.
It's the hypotenuse. According to A, we're comparing everything to A. And why A? Because it's the given one. That's why. Also, it's easier to think of things on the bottom. You don't have to use A. You could use 34. But we're using angle A. According to angle A, what is side B? Adjacent, or is it? It's the adjacent. Good. And from angle A, what is side A? It's now directly across. It's opposite. Now, we've got a couple of things to do now. Do we want to first? Okay, sounds good. Solving for A. A, side A, and we have 8.7. Hypotenuse and opposite. Which one involves hypotenuse and opposite of the sine, cosine, tangent?
Sin.
Sinner. It's the sine. Yeah. We're going to go with the sine. You're going to write this down. Sin 56 is equal to opposite over hypotenuse. First thing you do is that. Oh, didn't mean to do that. You write down the rule first, and if you have a number for the angle, you always put that in, and that's what we did. Then you're going to type that into your calculator. 0.829. 0.829. Now we're going to pretend that's comparable to the opposite side, the 829. What would we put on the bottom for the hypotenuse of a similar triangle? Because you can always use a denominator of 1. Always. You're just the joker to me. In this particular case, similar triangles. So we're saying one side is the opposite, one side is the hypotenuse. We don't know the opposite. That's our letter replace it with that particular situation. And the hypotenuse is 8.7. We can now solve for A. Cross multiply. Now, I'll give you guys a second to do that. You guys will tell me the answer in centimeters.
7.2 centimeters.
7.2. That's great. Awesome. Awesome. Oh, why do I keep grabbing the wrong things? I'm going to lock this down. Okay. That's great. I'll just scooch that over a bit because I want to work on the right here. I want to solve for B. B, and we still have the hypotenuse. The given information was adjacent and hypotenuse. Which one of the three gives adjacent and hypotenuse? Cosine. Cos it is. Cos 56 degrees is equal to adjacent over hypotenuse. That's the rule as written. Then you're going to get the decimal. I know you know how to get to you this time. 0.559 out of 1. Hit that button on your calculator. 0.559 is like the adjacent side. The hypotenuse is like the comparison. In this particular case, though, on our triangle, what do we put down for ADJ, for adjacent, from ours? We put down for hypotenuse. Don't believe the height.
8.7.
Okay, for which one?
For,
Well, what is it labeled as?
Centimeters.
oh, the bottom.
Yeah, the bottom of the, for the hypotenuse, right? Yeah. 8.7 is the hypotenuse. What do we put for ADJ?
B.
The letter. That's the best known. Yeah. Okay. Best to our knowledge, all we have is B. To solve this, you cross multiply. Divide by the loner, divide by 1. That doesn't change, it's multiplying in this case. And you get 4.9. I'll give you that one.
4.8.
4.8.
Okay, try 4.8. What's the number behind it, though? What does 6 tell you to do? 4.9. I make mistakes, though, so that's why I was checking. 4.9 centimeters. Okay? Yes. Must have been eating beans. You've got a bunch of triangles now. You guys know how to do all the sines and all the cosines. Finish up. Get this. This is probably the, well, this is one of the more important sections in Math 10, Workplace 10, because it carries over and you're going to, the sines, cosines, and tangents when you do 20. And you need to do 20 to graduate. Good luck. And I'll stop the recording.